All right, welcome. Today we're going to add what is seriously one of the most flexible and powerful tools to your algebra toolkit, the point-slope formula. So let's jump right in and see why this thing is such a game changer.
You know how it is, right? You're just cruising along with your good old y equals mx plus b. But then you hit a problem where you've got a slope and some random point, but no y-intercept. And suddenly, bam, it feels like you've hit a wall. But what if I told you there's a formula that's made for that exact situation?
Okay, here's a great way to think about it. It's all about giving directions. Your classic slope-intercept form, that y equals mx plus b, is kind of strict. It's like saying you have to start at the city center, that's the y-intercept, and then follow the directions from there. Point-slope form, though, so much more chill. It basically says, hey, just start wherever you are right now, any point on the line, and then follow the directions, which, of course, is the slope.
All right, so where does this magical formula even come from? Is it some brand new, complicated thing you have to memorize? Well, you'll be happy to know that no, it's actually not new at all. It's something you already know, just wearing a clever disguise.
Remember this? Our old friend, the slope formula? Rise over run, the change in y over the change in x. This right here, this is the bedrock of everything we're about to do.
So how do we get from that to our new formula? It's shockingly simple. You just start with the slope formula we all know. And then, check this out. There's just one tiny algebraic move. We multiply both sides by that x minus x1 on the bottom. Why? Just to get rid of the fraction.
And boom, that's it. I'm not kidding, that is literally all there is to it. What you're looking at right now is the point-slope formula. It's just the slope formula you've been using this whole time, just rearranged so it's not a fraction anymore. See? No new stuff to memorize, just a way more convenient setup.
Okay, let's do a quick anatomy lesson on this thing. The m, no surprise there, that's our slope. Then you've got x1, y1. Now this is the cool part. This can be the coordinates of any point you know is on the line, any single one. And the regular x and y, those are just the variables. They're what stay in the equation to define the whole line.
Okay, hold on. Before we jump into using this, we need to talk about something super important. There is one little trap, this one tiny thing that trips up almost everyone when they first see this. Any guesses what it is?
It is all about sign confusion. See, the formula has those minus signs built right in, y minus y1 and x minus x1. Because of that, you have to get into the habit of thinking opposite. So if you see x minus 3 in an equation, the x-coordinate of your point is actually a positive 3. And if you see x plus 5, well, that's just a sneaky way of writing x minus a negative 5, which means your coordinate is negative 5. Just burn this into your brain. Always, always take the opposite sign of what you see in those parentheses.
All right, theory's great, but let's get our hands dirty. The absolute best way to get this is to just do it. So we're going to walk through a few examples. First, we'll pull the pieces out of an equation, then we'll build one, and finally, we'll graph one.
Okay, example 1. Let's start nice and easy. We're given y minus 3 equals 2 times x minus 4. First up, the slope, m. That's the easiest part. It's just that number sitting out front of the parentheses. So our slope is 2. Now for the point. We look inside the parentheses. We see x minus 4. Remember the rule, opposite sign. So our x-coordinate is positive 4. Then we see y minus 3, opposite sign. Our y-coordinate is positive 3. So our point is 4, 3. See? Simple as that.
Okay, let's flip it around. This time, we're going to write the equation. We've got a point, 2, negative 5, and a slope of negative 3. All we do is plug them straight into the formula template. So it's y minus our y value, which is negative 5, and that equals our slope, negative 3 times x minus our x value, which is 2. And right there, that's the perfect example of our sign rule. Y minus negative 5 becomes y plus 5. So the clean final equation is y plus 5 equals negative 3x minus 2.
Okay, last example. How do we actually graph one of these things? Let's use the equation y minus 1 equals 1/2 x plus 3. It's a two-step process. Step 1, find and plot your starting point. And what's our number 1 rule? The sign rule. X plus 3 means our x-coordinate is actually negative 3. Y minus 1 means our y-coordinate is positive 1. So we find negative 3, 1 on the graph and put a dot right there. Step 2, use the slope like a treasure map. Our slope is 1/2. That's rise over run. So from our point at negative 3, 1, we go up 1 and then run to the right 2. Put a new dot there. And that's it. Connect those two dots with a straight line and you have officially graphed the equation.
Okay, so at this point you might be thinking that classic student thought, This is cool and all, but when am I ever actually going to use this? Totally fair question. So let's talk about why this formula really matters, both in the real world and for avoiding those annoying traps on a test.
Okay, picture this. You're a scientist running an experiment. You probably don't start your stopwatch at the exact same millisecond you begin the reaction, right? Instead, you might look at your notes and see, okay, at the 5-minute mark, the temperature hit 40 degrees. What did you just record? You recorded a data point. 5:40. And here's the key. That is not the y-intercept. That's just a point in the middle of the experiment. Point-slope form is the absolute perfect, most natural way for that scientist to model their data.
So let's just hammer this home one more time. The 2 biggest traps to avoid. First, and I'm going to sound like a broken record, but it's that important, watch those signs. Always take the opposite sign you see in the formula. And second, just read the directions on the problem. If it asks you for the answer in point-slope form, just stop there. Don't automatically start distributing and trying to turn it into y equals mx plus b. Give the answer in the form they asked for.
All right, as we start to wrap this up, I really want you to shift your thinking. Don't just see this as another formula for another specific type of problem. Think of it more like a key that's going to unlock some really cool, more advanced math later on.
And here's why it's so important. Down the line, in something like calculus, you'll be doing this thing where you find the slope of a curve at one specific instant. And what information will you have? You'll have, you guessed it, a point and a slope. And this point-slope form, it becomes the #1 go-to way to write the equations for those lines. So if you master it now, you're setting yourself up for some major success later.
So if there's one single idea I want you to walk away with today, it's this. Please, don't think of point-slope as just another rule to memorize for a test. See it for what it truly is. It's the slope formula, something you already get, just shuffled around a bit to be way more useful in certain situations. And that kind of leaves me with one last thought for you to chew on. As you keep going in math, start looking for this pattern. How many other new rules that you learn are really just old ideas you already understand, just presented in a new, clever way? If you start thinking like that, this whole subject becomes a lot less about memorizing and a whole lot more about connecting the dots. Thanks for tuning in.